As human actions are driving very fast changes in climate, the usual climate experienced by plants and animals might become hotter, drier or wetter, and it will be more unpredictable, disrupting where these organisms can persist in the future.
So in order for us to anticipate the effect of environmental changes on the redistribution of species of plants and animals on Earth, we need to understand how different climate conditions affect the performance and the persistence of different populations in different locations on Earth. So we looked at the responses to climate of about 100 populations of trees and herbs in 16 different countries over different continents.
So our understanding of species distribution can be usually improved by trying to build models that captures these species requirements and then use these models to predict species distribution in space. We live in a world of big data. We have huge data sets for species observations in world repositories, including millions of observations of species occurrences in the field. But we also have big data for environmental data as obtained by satellite imagery, by digital elevation models from which a whole suite of environmental predictors can be derived. But we also have increasingly large computer facilities that allow running many models for a large number of species at the same time. But one thing that is really important behind this model is based on a concept that is called the environmental niche of species, which is the envelope of environmental conditions that a species needs to develop and reproduce. Therefore, with the development of these models, we also made huge progress in our understanding and quantification of these environmental niches. So, as a next step, maybe one of the pressing questions is whether we can predict the performance of populations depending on where they lie within this niche, where they are located, if they are close to very good conditions or in the margin of this species niche.
Well, what we do is we use really abundant data, big data that we have on the presences of species under current climate conditions all over the world. And then we build a model of where we think the climate is most suitable for that species. And then the novel thing that we've done is put those maps together with data from Compadre, which is a big database of species growth, survival and reproduction. And we can, for individual species then, we can map climate suitability relative to their growth, their survival and their reproduction in those locations. So we find that some plant species are able to persist in these really low suitability climates, and they have quite a limited strategy for doing that. And the strategy is to shrink in size and survive. And this enables them to resist local extinction for longer than we might have expected. So that's the good news story.
We are now starting to think of shrinkage as one of the life history traits in the full repertoire of the plant kingdom, whereby plants that have got the ability to decrease in size may be better positioned to deal with unsuitable conditions.
In poor climates, we find that reproduction is much more variable. So there's good years and poor years for producing offspring. And we also find that for trees, growth is much more variable. Again, you have good years and poor years for growth. And it's this variability in growth that makes trees much more vulnerable to extinction in these poor climates.
These results are key to understand how plants respond to climate change. Not all plant species are equipped with the necessary life history strategies that enables them to resist the challenges of climatic changes in particular locations for a long time. So in the future we will hopefully find out which plants are more able to do so and which will die out faster from these locations of interest. And with this knowledge we will also be better equipped to design the management strategies directed to ensure the continued provision of food and other types of ecosystem services that these plants and animals are providing to us, and to preserve the biodiversity for future generations.